Hello, everyone. We're going to be starting hypothesis. And hypothesis testing is a complicated process that has many steps and often throws students off. But in this video, I want to convince you that the idea is actually pretty simple. To explain hypothesis testing, we can imagine this scenario. There's a certain high school football team that uses its lucky coin at home games. This team always calls heads, and they seem to win the pre-game coin flip a high percentage of the time. Their opponents believe that the coin is biased to come up heads. So the opponents want to disprove the claim that the coin is a fair coin. So in this scenario, the State Athletic Association decides to investigate P, which is the probability that the coin comes up heads. This is actually the proportion of the time that the coin comes up heads. P stands for proportion. So we have two competing claims. The first claim is that the coin is fair. Heads and tails are equally like. And in that, we would be looking at P is equal to 0.5. Counterclaim is that the coin is not fair. And so that would be the statement that P is not equal to 0.5. In statistics, a statement that a value is equal like this is called the null hypothesis. And the reason it's called the null hypothesis is it means nothing is wrong. Nothing is out of the ordinary. Everything is as people expect. And this competing claim is called the alternative hypothesis. Now, let's take the perspective of our high school football team. We want to prove the alternative hypothesis. So we believe the alternative hypothesis to be true. To see if this coin is fair, we devise an experiment. We flip the coin 25 times and decide and record how many heads there are. And then we decide what probability we are willing to accept. So in this case, we're going to say if we see a result with a probability less than 0.01, we will not believe the coin is actually fair. If we see an event that occurs with a probability less than 0.01, that means we're seeing something that's extremely unlikely. And if we see something that unlikely, we say, well, maybe our assumptions are wrong. Maybe the coin isn't actually fair. So suppose we flip the coin 25 times and it comes up heads 23 times. Is this enough evidence to believe the coin is unbiased? Or to put it more accurately, is this enough evidence to reject the idea that the coin is fair? So let's think about how likely is it that we would get 23 heads or more. So our probability calculation, how likely is it we would get 23 or more heads with a fair coin flipped 25 times? Well, we can do this calculation using the binomial, but however we do it, let's get that p-value, which is a capital P now that stands for probability. However we get this probability value, if you do the math, you will get that the probability value of getting 23 or more heads in this scenario is this incredibly small number, 0.000009. That's incredibly unlikely. That probability is so small, it's basically zero. So because this is so unlikely to occur, we conclude there's no way this is a fair coin. If this were a fair coin, this would be a miraculous occurrence to get 23 or more heads. We reject the idea that this is a fair coin because the probability we would see this result is so small. So these are the steps in what we're calling hypothesis test. First, we have a claim and a counterclaim. We have a null hypothesis and an alternative hypothesis that we need to set up. Then we decide, we collect some data. In this case, that was flipping the coin. And we decide what probability of unlikeliness we're willing to accept. So if we see a result with a probability less than some number we decide, we will not believe the original claim, the null hypothesis. Then we do the probability calculations. So if I were looking at this, I would look at setting up the claim, step one. I would look at deciding on my decision criteria, which is step two. And I would look at step three, which is my probability calculation. Finally, based on the probability calculation, I would then draw a conclusion. Whether or not the probability I looked at was strong enough to justify that this event was so unlikely, I don't believe it could occur if the original claim were true. So that's an overview of hypothesis testing. In everything we do moving forward, hold on to those 4 steps because they'll be extremely important.